Hi and welcome back. In this video segment we are going to be looking at the parabolas and properties and how they relate to the function or the equation. So just a reminder, our standard form of a quadratic equation is ax squared plus bx plus c equals y, where a is greater than or equal to 1. Remembering we have to have that squared term in order for it to be a quadratic equation. However, what happens when b equals 0? How does that simplify? Well, it comes down to ax squared, when we put 0 in, that middle term disappears, plus c equals y. Still a quadratic, I still have that squared term, and the graph of ax squared plus c equals y is still a parabola, but my axis of symmetry is going to be at x equals 0, and the vertex is always going to be at 0 and the value of my constant, so 0c. When we go about graphing some of these parabolas, first thing you want to always do, I think, is graph that vertex. Know where you're starting. Then you're going to make a table of values just like we did back in Algebra 1 for x and y, and you're going to pick a few points on the same side of that axis of symmetry. Graph them and then graph their coordinating points on the other side of the axis of symmetry, and then go ahead and sketch that curve. Let's take a look at our first example. If we notice our example 1, graph the function of f of x equals negative 2x squared plus 2, I don't have that linear term. There is not a bx term here. So if I paid attention, my axis of symmetry is going to be at x equals 0, and the vertex is going to be at 0 and the value of that constant, 0, 2. So I'm going to go ahead and I am going to and I picked red on purpose so you can see that on that black graph paper, and draw in my x and y axes. And first thing I need to do is graph my vertex at 0, 2. Next is create a table. So I'm going to make an x and y, and remember f of x and y can be swapped easily. So I'm just going to pick values for x, substitute them in, and see what the output is. So if I select 1, that means I'm going to have f of 1 equals negative 2 times 1 squared plus 2, or negative 2 plus 2, which equals 0. I have a point of 0, 1. Next, I want to pick points on the same side of that axis of symmetry. So I think I'm going to select point 2. See what happens when I put 2 in. So I'll have f of 2 equals negative 2 times 2 squared plus 2. That's negative 2 times 4 plus 2. Negative 8 plus 2. Negative 6. And for our purposes, 2 extra points in the vertex, that's plenty. So I'm going to go ahead and graph 0. How about 1, 0? 1, 0 is here. And 2, negative 6. 1, 2, 3, 4, 5. Woo, right at the bottom. Remembering that I have coordinating points on the other side of that axis of symmetry. So this point is 1 away from the axis of symmetry, so I'm going to come 1 out, and I'm going to put another point here. My 2, 6 is actually 1, 1, 2 spots. So I'm going to go 1, 2 spots and put a point there. Now I simply connect the dots. and see where, and that sketches my graph. So my curve or my parabola, I'm just going to connect my dots and determine that there I have my parabola. It opens down. I'd like you to take a few minutes, pause the video, and graph example 2, which is f of x equals 3x squared minus 1. You're going to need at least 5 points, the vertex and 4 other points, 2 on each side of that axis of symmetry. Pause the video now. When you're ready to check your answer, go ahead and hit play. Well, let's see how you did. Once again, we don't have a linear term, so I know that my axis of symmetry is at x equals 0, and my vertex is 0, and then the value of my constant, -1. So let's go ahead and graph that. I'm going to change the color of my pens here. And I'm going to draw in my x and y axes. Graph my vertex 0, -1. Then go ahead and make a chart, x, y, and select values on either the right side or the left side of that axis of symmetry. It doesn't matter. I'm going to select 1. So I have f of 1 equals 3 times 1 squared minus 1, which is 3 minus 1, which is 2. Then let's just go ahead and pick 2. So I'm going to have f of 2 equals 3 times 2 squared minus 1, 3 times 4 minus 1, 11. Graphing my points, 1, 2, and then 2, 11, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We'll put it way up here. And then looking at my parabola, my point 1, 2 is 1 from that axis of symmetry, so I come out 1 from the axis of symmetry here for its coordinating point. And 2, 11 is 2 away, 1, 1, 2, so I go 1, 2 and put it here. Now, if you were smarter than me, maybe you picked different points, but you're going to end up with a 211 or -211 either way. The graph paper is just a little small. So here we're going to go and we're going to connect our points and sketch the curve of our parabola in. Hope you did well with that. Sketching them, it's really quite simple. The axis of symmetry is x equals 0 and the vertex 0, c when we do not have that linear term. When we have our equation in the form ax squared plus bx plus c equals y, and b is not 0, both the values of a and b affect the position of the axis of symmetry. And we can use our values of a and b and c to find characteristics of the graph. Now, if a is greater than 0, meaning it's positive, the graph opens up. If a is less than 0, negative, the parabola opens downward. So up, it would open up with the opening up, and when we're down and negative, it opens down like a frown. Now, the axis of symmetry, we can use the values of a and b to determine that. The value is x equals -b over 2a. So we substitute in the values of a and b And so we can figure out and determine where that axis of symmetry is. The x-coordinate of the vertex is still the same as my axis of symmetry, so negative b over 2a. The y-coordinate is simply plugging in the x value and determining what y is. So we're going to input negative b over 2a and see what that output is for my y value. And the y-intercept, where does it cross? 0, C. So let's take a look at example 3. Let's take a look at f of x equals x squared plus 4x plus 2. Label the vertex and the axis of symmetry. We can tell a lot about this graph from the equation. First, a is 1, so it's greater than 1, so I know that my parabola is going to open up like that. Next, to determine my axis of symmetry, where can I fold it in half? I'm going to use negative b over 2a, and that equals x. Sorry about that. So x equals, b is 4, so minus 4 over 2 times 1 equals negative 4 over 2, or x equals negative 2 is my axis of symmetry. My vertex is, well, I know the x is negative 2, so I need to see what happens when I input negative 2 to determine the y value of that coordinate. So f of negative 2 equals negative 2 squared plus 4 times negative 2 plus 2. Negative 2 squared is a positive 4. Negative 2 times 4 minus 8 plus 2. 4 minus 8 plus 2 is negative 2. So my vertex is negative 2, negative 2. And then I'll need to find some points. So I'm opening up. So I'm going to start and put, woo, I thought I was going to have a straight line. Little did I know. Um, put my axes in for x and y. Graph my vertex. That's my first step. Negative 2, negative 2. And then I know that this is going to be my axis of symmetry. Now, I need to find points on one or the other side of this graph. So I make an XY table. The easiest point to find is 0. Substituting 0 in for x, I'll have 2. And I also think I'm going to put in negative 1 this time. So f of negative 1 equals negative 1 squared plus 4 times negative 1 plus